This lesson is on solving simultaneous equations using the elimination method. So last lesson we solved simultaneous equations using the substitution method. This lesson will be using the elimination method, which is a little bit different. Both methods are quite important to know because you can be asked specifically to solve simultaneous equations using a particular method. So they're both important to know. Let's just work through two examples to demonstrate this method. So question 1. Solve x plus y equals 7 and 5x minus y equals 5. And I'll write down here by elimination. Now, we could solve these simultaneous equations using the substitution method if we were to say take this first equation, rearrange it to make y the subject, so we'd get y equals 7 minus x, and then we could sub that y into this equation here. That's a perfectly valid way of doing it, but as I said, sometimes you'll be asked specifically to solve simultaneous equations using a particular method. So when we're solving by elimination, our first step is similar to substitution. We'll just write out both of the equations and label them for reference. So we've got x plus y equals 7, let's call that 1, and 5x minus y equals 5. Let's call that 2. Oop. Alrighty, now what we want to do here is we want to eliminate one of the pronumerals. So because we're dealing with a 1y here and a 1y here, if we were to add these two equations together, so if we add equation 1 plus 2, we'll get x plus 5x gives us 6x, y plus minus y plus minus y equals 0. So that eliminates the y's there, and we'll solve 6x equals 12, which we can easily go ahead to find x equals 2. Now, as with the substitution method, we can take x equals 2, so sub x equals 2 into equation, and you can pick either of the equations, it won't make a difference, but equation 1 looks a little bit easier to work with, so let's choose that one. If we let x equal 2, we'll get 2 plus y equals 7, so y equals 5. Therefore, our solution is x equals 2 and y equals 5. So just recapping what we did there, we added the two equations together, and when we did that, we eliminated the y's so that we were just solving for x. We found out x, and then we could substitute that x into either one of the equations to find our y value. Now this step here where we added the two equations, we don't necessarily always add. Sometimes we'll subtract. Sometimes you'll solve equation 1 minus equation 2. It depends on the signs in front of the pronumerals that you're trying to eliminate. Now let's have a look at another question that's a little bit trickier. Let's solve 3x plus 2y equals 6, and 5x plus 3y equals 11 by elimination. So our first step again is to just rewrite both of your equations and label them just to get you started. So let's call 3x plus 2y equals 6 our first one. 5x plus 3y equals 11. We'll make that our second one. Now, notice the difference between this question and the previous one. In the previous question, the coefficient of our y value of our y pronumeral in both equations was 1. So it was quite easy just to eliminate them with a simple step. In these equations here, our coefficients for all of the pronumerals are different. We've got a 3x and a 5x, and we've got a 2y and a 3y. So we can't just simply add these two together or subtract them from each other, because that won't actually eliminate either of them. So what we need to do is multiply the equations by certain values so that we end up getting the same coefficient of y, or the same coefficient of x. So let's multiply equation 1 by 3. So multiply equation 1 by 3. That's going to give us 9x, 3x times 3 is 9x, plus 6y equals 18. I'm going to call that equation 3. If we multiply equation 2 by 2, that's going to give us a 6y, which we can then eliminate with this 6y here. So if we multiply equation 2 by 2, we'll get 10x plus 6y, 3 times 2, 6, equals 22. And we'll call that equation 4. So notice how this is a little bit more involved than that previous one. But now we're in a position to eliminate these y's here. We've got a 6y and we've got a 6y. So if we subtract equation 4 from equation 3 from equation 4, we will get 10x minus 9x will give us x. 6y minus 6y will give us nothing, so they cancel out, and we'll get 22 minus 18 equals 4. So there we've got our x equals 4. Now we haven't quite finished. We need to substitute this x equals 4 into, again, either one of these equations. It doesn't matter. Let's choose equation 1. So we'll get 3, and then if we sub in x equals 4, 3 times 4, plus 2y equals 6. So that gives us 12 plus 2y equals 6. Bring the 12 over to the other side, we get 2y equals minus 6, and therefore y equals minus 3. So the solution to this pair of simultaneous equations is x equals 4, y equals minus 3. And if you were to substitute those values back into these equations, you would find that they would satisfy both of them.